Every recipe app works the same way. You type chicken, you get chicken recipes. You type pasta, you get pasta recipes. But that's not how we think about food. I don't think chicken. Literally, I think something warm and cozy, the kind of thing I want on a rainy evening wrapped in a blanket. You know, so no app understands that. So today we are going to build what that one does that using a vector database called Qdrant. Here is the core concept before we touch any code. Normal search works on keyword. It looks for matching words. So if you type like cozy winter food and recipe says warming, hearty stew, normal search misses it completely. You see, not keyword match. Vector search works on meaning. It converts your text into a list of numbers. We call it a vector. That represents what your word even mean, and it converts every recipe into a vector too. Then it finds the recipe whose meaning is closest to your query. Yes, that's it. That's the whole idea. So let's build it. We'll require four packages. Quadrant client, which is basically a vector database we are storing everything in. Sentence transformers, which is a model that converts texts into vectors, totally for visualization at the end. And scikit-learn for visualization trick we'll use later. So we'll run this cell to check if our imports are successful or not. As you can see, all of our imports are successful. Then we'll load this all mini lm l6v2. I've already ran this, so let's run it once again. So as you can see, model is ready, which basically means like these 384 numbers are the meaning of that sentence in mathematical form. Two sentences with similar meaning will produce similar numbers. So remember that thing. It will basically take any sentence and output 384 numbers. As simple as that. So let's get to our third step, which is our recipe database. As you can see, there are 30 recipes. But look how they are described. This is a key part. Each recipe has flavor profile field, not just ingredients, not just a list of steps. It is a description of character of the dish. So let's read one out. Let's read this one: creamy tomato based curry with tender chicken, warmly spiced with garam masala, cumin, coriander, rich and velvety sauce, slightly tangy from yogurt, bold but approachable, cozy, fragrant, deeply satisfying. And let's read one more: complex pork bone broth shimmered for hours, deep umami, rice, slightly fatty, topped with tender chashu pork, soft egg, nori, warming, soul restoring, a meal that demands patience but rewards completely. And this is what we are embedding into vectors. Not the recipe, the feeling of that recipe. That's what Quadrant is going to search over. So let's run it and let's see how it looks like. So as you can see, all 30 recipes have been loaded. 17 cuisines, 12 meal types, all are unique. French are 6, Italian are 4. So yeah, so on and so forth. Now next step. This is to set up Quadrant and build flavor index. One can use Quadrant in memory, which requires no sign up, no server, which can run locally. But here I will prefer you to use the production one by getting your own Quadrant URL, which is basically your endpoint and your Quadrant API key. Correct? Once you get this and this, you can use it on the production level. Because if you use this, you'll be able to visualize things on the better level. You'll be able to go there and check how it actually looks like. Correct? So with the help of this code, we'll create a collection. Think of it like a table in a regular database. Except instead of storing rows of data, it stores vectors. We set the vector size to 384, if you remember, to match our model. And we set the distance metric to cosine similarity. So let's run it. Yeah, as you can see, if there was any previous collection, so it was deleted. And it has connected. as you can see, and it has also made the collection which is recipes. Now I want you to focus on this cell, correct, and this thing, point struct. Here we are looping through every recipe, embed the flavor profile into vector and push it into Qdrant as point struct, as I pointed it out already. That's Qdrant document format, a vector plus a payload, which is where we attach all the metadata like name, cuisine, difficulty, time to cook, let's say. Let's run it. And once this is done, as you can see, yeah, all 30 recipes indexed into the Qdrant. So Qdrant builds an internal index, so it can search through all these vectors in milliseconds. Even if you had a millions of recipes, the search time barely changes. Now here is my favorite part. The search function does three things. Takes your text query, embeds it into vector using the same model, calls client.search in Qdrant, which compares your query vector against all 30 recipe vectors and returns the closest ones by cosine similarities. So let's run this and make our function ready. As you can see, our function is ready. So let's look at this thing. There's an example. I've already ran this, but let's run it once again. And let's check the results. As you can see, the results are here. So let me explain this. First of all, this is a thing which you have to notice, which is 40.9%. So this is a match score. You will see basically, if you see 40%, it means it is 40% accurate. But if it was 80% accurate, or let's say 90% accurate, which is near to 100, right? It means cosine similarity is closer, you can say, right? It means the meanings are more aligned. But right now it is 40%, as you can see. So definitely we can make our entire code better, and we can improve this this matching this cosine similarity percentage, right? Whatever the percentage might be. Let's say I'm searching here something warm and comforting for a cold rainy evening at home. So it has searched warm, cakey exterior giving way to a river of molten dark chocolate. As you can see, intense, bittersweet. So it is matching. But I want something more which is like, which is more accurate, let's say. Right? So for that, what we'll have to do, we'll have to increase the increase our cosine similarity. So for that we'll just have to simply tweak our code. So first thing which you should notice is this 40.9%. So this is cosine similarity. It can be anything 40, 50, 60, 70, 80, 90. So if it is near to 100, it means it is more aligned to the meaning. But if it is only 40, it means it's not even halfway through. But definitely we can tweak our code and make it in such a way that it literally can align more with the meaning. But right now it is not, but it is fine. Let's look at the results. For now. So I have searched for the mood, which is something warm and comforting for cold rainy evening at home. So the suggestion is warm cakey exterior giving way to a river of molten dark chocolate, intense bittersweet, as you can see, and the result is chocolate lava cake. So yeah, this is very much accurate. Like if I am in this mood, then I would definitely want to, like, I would eat this, correct? But then these things are not that accurate, right? Like beef stew, Vietnamese food, let's say, right? So definitely we can do some tweakings here and there, make it more aligned with the meaning and make it more accurate, correct? Now let's look at this thing, an elegant showstopper that will impress guests at dinner party. So yeah, seared duck breast with cherry sauce. So this is very hard to make, as it is saying, but similarity is again 36.8%, right? But as you can see, if we look at it in a very practical way, so this is definitely good for let's say, like, dinner party. But a beef wellington, like lemon chicken piccata, mac and cheese is not that great for if guests are coming, let's say, right? But lobster bisques is also good, right? As you can see, the score is also here, right, like 36.8%. So it is saying like 36 3.0.367. So if it was closer to 1, it means it was more accurate, right? But at least for the meaning part, it is definitely matching it. Like it is definitely understanding the context of it. So let's run this thing. Light, fresh, bright, something that tastes like sunny afternoon. Let's see what it is giving us. So it has given Capri's salad. Somtum, I don't know what this is. Then seared duck. As you can see, look, this is good for dinner, but not that great for, let's say, sunny afternoon, right? This is not light, correct? So yeah, definitely we can work on its tweaking. So we can definitely improve it together and make it better. Let's get into our sixth step. And here is a neat trick which I will tell you. Every recipe already has its vector stored in Qdrant. So for make like this, we don't need to re-embed anything. We just call client.retrieve to pull the existing vector back out and use that as search query. So if you love ramen, like Japanese ramen, the system suggests French onion soup, for example, beef stew, Vietnamese pho. These have nothing in common ingredient wise, let's say, but different cuisines, different proteins, completely different cooking methods. But their flavor, right, vibe is very same. Deep, slow, warming, complex broth. The vector math picks that up. So let's run this and look at it. Look at this. As I've already told you, if you love Japanese ramen, you might also enjoy this. And as you can see, cosine similarity is halfway through. Here, it has crossed more than 5. So let's see. This beef Wellington. If you love this, you might love seared duck breast with cherry sauce. Sorry. And if you love pad thai, then you might like somtam, green papaya salad. It has crossed more than 6 similarity, right? 0.6, I mean to say, correct? As I have said, this dish has nothing to do with this, but the vibe and the, like, the whole flavor and the broth is very similar in them. That is why. Now this is my favorite cell. This is what you can say is, here we are going to make some sort of plot. This is a space map, you can say. We will pull all 30 recipe vectors back out of Qdrant using client.scroll. As you can see here, this is. We then use PCA, a math technique, to compress those three 84 dimensional vectors down to just 2 dimensions, so we can plot them on flat chart. So let's run this and let's see how it looks like. Boom. Here is the result. As you can see, every dot is a recipe and they have naturally grouped by flavor, personality. The comfort foods like, let's say, ramen, beef stew, French onion soup are neighbors. Not because they are same in cuisine, because they have same feeling. The fresh dishes clutter over here, right? Like here, like this has nothing similar with anything. That's why it's alone sitting here, right? The model learned the geometry of taste just by reading our descriptions. We never told, right, like how we want to group this. It figured it out by itself. As you can see, like Korean barbecue, bulgogi, and then chicken tikka. Look at this. So these two things are very, very close to each other. These things are very, very close to each other, right? Look at this, right? This is American cuisine, and this one is French cuisine. The name is French onion soup, and this one is Texas BBQ brisket. Isn't this beautiful? And below this there is a recipe flavor space, but now this is no, sorry, below this is again a flavor space, but now this time we have grouped by the meal type, right? So as you can see, name is Greek salad. So now here we have caprese salad. Then we have, let's say, somtam green papaya salad, right? As you can see how beautifully these three have clustered together because they all are salads, right? This is what I wanted to show you. So what actually happened here? We took recipe descriptions, not ingredients but feelings, and converted them into vectors, sentence transformers. We stored those vectors in Qdrant, and then when you type a mood like certain type of vibe, it converts that into vector too, and it finds the nearest recipe in meaning space. The reason this works that is that the embedding model was trained on massive human data already. That is why it understands, like it feels like a hug, cozy, warm, comforting, indulgent, nostalgic, all these things. Quadrant job is just to store those vectors and search them fast. And the cool part, this same architecture works for anything where meaning matters. Let's say you want to search movie by vibe, or any video by its vibe, or like something like that. Maybe the song or the genre of song you want to search. So yeah, that was it. So yeah, if this was helpful, hit like, it genuinely helps us. See you in the next one.